Okay, so there's one last kind of motor, and they look a lot like this. And this is a brushless DC motor, all right? And in FIRST Robotics, we're moving completely away from brush motors and almost entirely to brushless motors. And the reason this is happening is that we get a lot more power, and the motors have to have an encoder in them. Now, what's different between a servo motor and a brushless DC motor? Well, in a servo motor, we're sending an AC signal, sine wave. Okay. In a brushless motor, there's they put magnets on the rotor. They put magnets and they have a sensor, and the sensors, typically three magnets, three sensors, and what happens is that they are actually turning on the DC when the sensor says you're in the right position. So as it goes around, the different poles go on based on the sensor position. But it's not sending a sine wave, it's sending DC to coil, and it essentially is kind of stepping, all right? So the ones we're using in FIRST, they have the sensors built into the motor, and then there's a controller that goes with it, and the controller then has three power wires coming out of it to the motor, so you can tell that it's got the three phases in it. But it also has a cable coming out of the motor, which is from the sensors that tell the drive where the motor's positioned. So it's actually turning on these coils as the motor goes around, based on these sensors sending back that they are positioned in the correct location. So the advantage of these is that, again, no brushes, no maintenance, and again, what fails in an electric motor? If it isn't overloaded, it's only one thing: bearings. Bearings are pretty much everything. Now, there are cases where motors are in adverse environments where there's a lot of moisture and stuff, and so you can have breakdowns in the windings and things. But nowadays, you don't see much of that. So those are the different kinds of motors. Servos are high-end motion. Steppers are low-end motion. Induction motor or synchronous motor or permanent magnet motor with a VFD is a lower yet level of motion control. So we tend to use this on conveyors and so forth. We can control the speed and direction and all, and then steppers get used where either low power and you still need positioning, and you don't want to have to put a lot of sensors in. Now, important thing, all the positioning systems need to know where they are. So in every case, you need to have something that you call the home position. So in the case of stepper-driven systems, your little 3D printer has limit switches, and the motor moves to the limit switches and says, okay, I know where I'm at, and now I'm going to count steps from that position. Same thing with the servos. We have to have a limit switch, let's say. Some systems, they will always park the motor at a specific spot in its motion, and then the encoder has what's called an index signal, which is just it says that the rotor is exactly lined up with that. And so what happens is when you power the motor on, it goes and it looks for the index signal by just turning the motor one revolution, or half a revolution essentially. So you have to park within half a revolution, and that's used on some machines. The problem with it is that if you powered the machine off and parked it someplace else, it doesn't know where it's at, and you have to wind up manually moving it to the correct position and then homing again. So that's pretty much how it all works.
Great.
Thank you.